Good morning, everyone.
Good morning.
Thank you. Are we recording?
Yeah.
All right. Thank you. Thank you. So, once again, we've got a lot to cover and not a lot of time to cover it in. Thank you for your endurance. I'm actually losing track of like which courses, classes I do online and which ones I'm having to make up. It's like just a complete schmozzle. Last 4 weeks have been given a gift from the devil himself. So, we have one slide left to cover in our roughshod introduction to C programming based on previous knowledge. We will then have a briefer topic on the subject of revision control, subversion, etc. Although it may not seem like it at the moment, I'm trying to do everybody in this room a favor by giving you knowledge that will be expected of you at some point, but is never actually explicitly covered in the curriculum. Today we will be covering it explicitly in the curriculum, so please pay attention, because the software engineering professors will expect you to know how to do this without ever having actually been taught it, so, you know, here we go. So anyway, let's continue this though. So we were talking about loops. Very briefly, while loops in C and in Python are basically exactly the same organism. However, for loops are a very different organism. The for loop in Python is much closer to some languages for each loop, which iterates over the elements of a data structure. In the case of a for loop, even a for loop in C does not iterate over the contents of a data structure unless explicitly told to do so inside of the body of the loop itself. What you've got is an initializer, an update, and a condition, which is what your traditional structure is for a loop anyways, collected up into one thing. This is an improvement over the while loop because it will gripe at you and give you a syntax error if you forget to include the increment in this. And everybody knows that what's the most common cause of infinite loops? Forgetting to update update the index variable, right? So, yes, good. For loops, if you're using that structure, they constrain you to use that structure, and that's useful. But otherwise, there's actually no semantic difference between a for loop and a while loop if you just take, like, this guy, put it here, and take that guy, put it there. Make sense? Any questions? Good. So, further on the subject of loops, we were kind of talking about gotos a little bit, and talking about how gotos are terrible, and you should never, ever, ever, ever use them. That being said, breaks and continues are basically a style of goto, which is bound to the context of the loop in which they exist. So, break statements break you out of the loop that you're in. They jump immediately to the termination point of the loop, right? So, it's actually absolutely fine for you to write an infinite loop, you know, while 1 equals 1 or something like that. So long as you're breaking out of it properly, it's not an infinite loop. This is one of the reasons why program termination is, there's no program that can be written to decide program termination, which is a famous result in computer science. So breaks can be very useful for programs with complex logic. Breaks are also used, as we saw previously, in switch statements, where they more or less have the same function. They just take you to the end of the structure. Continue is a little bit different. Continue jumps you back immediately to the beginning of the current loop. Jumps immediately to the next iteration of the current loop. So you jump right back up to the top of the loop again. right? Applications for this are not as numerous. Most people use if branching not to execute the rest of the code inside of a loop. So basically what a continue will allow you to do is skip the rest of a loop iteration and just jump to the next one. Most people just toggle that code with an if statement rather than use a continue. And it's much less useful than a break statement because a loop will continue to its next iteration anyways at the end of its current iteration regardless what you do, whereas break is actually doing something different from what it would do normally. So, continue, I've been programming for many years and I cannot remember a single instance where I've actually used a continue statement, but breaks are useful. You should know they exist though. Any questions? Yes, sir?
You have if statement for you can have a break in that if statement. Break out the if statement or
Oh, break applies, they don't break out of if statements. They only break out of loops and switches. Good question, though. Yeah, break statements don't jump you out of if conditionals. In fact, you know, most of the time when you want to use a break statement, you want to break conditionally. So you'll have like an if statement that just contains a break. That's a very common construct. Question?
So is there like a pass statement? So like same as
Pass statement. I don't know. Does C have a pass statement? Let me see. So, wow. Does C have a pass? Come on. Sure you would pick now. Doesn't look like it. So I think that was very much an inconclusive sort of thing. Yes, close all. Get out of here. Yeah. Any other questions before we move on to Git? No? Have I lost control of the class because you found out that I listened to Dragon Quest music? It's very relaxing, okay? Judging a man for his music choices. I thought you were raised better than that. Of course, I don't know hardly anything about you, so... Alright. That's scary. Okay. So, it seems I have too many topics up here for the number. Alright. We're going to talk about operating systems. We're going to talk about why Unix/Linux is superior. That's going to be official course content. And then we're going to talk about Git. Alright? So, I've already kind of talked about this a lot, but let's just go over it. So, operating systems. Memorize this diagram. It'll be on the test. Incidentally, the version that I use is Mint, and it would fall along that branch right there. It's Ubuntu derived, which is itself Debian derived. People who use Arch. Any Arch users in the crowd? No? Not surprising. So, Unix. Unix, the uniplexed information and computing surface. Unix was originally written in assembly code, which would have been a chore, but after the development of C, the Bell Labs gang re-implemented the Unix kernel in C, and it has remained in C ever since. Due to its low cost and high portability, especially to low-cost hardware, Unix was widely adopted by academic institutions and from there the world. Because everybody knows that if you train students on a particular technology, they will take their training with them forward into the workplace. And within a few short decades, that technology will overwhelmingly dominate. This is the game. This is why there are so many Coke machines on campus and no Pepsi machines. It's because Coca-Cola has an exclusive contract with the university so that there are only Coke machines on campus so that all of you become addicted to Coke so that you will carry that addiction forward with you into your lives. This is how the game works, right? And the Coke thing is just a microcosm of everything else that's going on. Like, honestly, undergraduates such as yourselves, loosed from the tender bonds of your family and making decisions for yourselves for the first time in your goddamn lives, are ripe fruit for the picking for these people. So, live virtuously, I guess. But anyway, so, Unix has had some key innovations versus previously existing operating systems, which are now so well ingrained in operating systems in general, it may shock you to know that these were innovations at one point. Number one, a hierarchical file system with folders. This was an innovation for Unix. The universalization of almost all file formats as new line delimited plain text. Before that, a lot of it was in binary code. And you had to know binary code in order to program a computer. You had to know binary extremely well. Once new line delimited plain text, or the widespread adoption of characters became a thing, people who didn't even know binary code could program. And that just ruined the whole discipline. A pervasive philosophy of modularity and code reuse, and the establishment of a set of cultural norms for software development practice. This was really the crucible in which the whole practice of software engineering was forged. So, operating systems in general then. I kind of did the one diagram on the board about this, but you know. So, operating systems provide an application programming interface to the computer's user programs through a series of software layers which eventually results in access to the system's hardware. When you declare a variable, you are accessing the hardware, right? When you are calling printf, you are accessing the system's hardware. Everything ultimately results to or from something to do with hardware because, you know, contrary to what the software engineers are going to think, you know, even programming code exists in physical media, right? We are not yet to the cyberpunk dystopia where everybody gets to exist inside of the data plane and in the cyber surf city made from, you know, the interstitial mechanics of the universe. Not true. Everything is in electrons. Anyway, so yes, the user applications are anything from internet browsers to word processors to solitaire. Your C programs that you're writing in the course of this course count as user programs, right? If you write very, very good user programs, someday you may be invited to write programs for things further down the line. I know, for example, one of my former TAs was had an internship at IBM, and he contributed to the Clang C compiler, which would be like, I guess you'd call it in there, because it's not a driver, but it's definitely like a OS utility, but when you're running it, it's user mode. Anyway, doesn't really matter. So the API provides system libraries and other utilities via system calls. These are typically executed by the kernel. The kernel is the hard nugget at the middle of the computer that makes everything work. When you allocate memory, you have to convince the kernel that you deserve the memory. Everything is a negotiation with the kernel. So, operating systems include a kernel, which manages access to memory, read-only and random access to the CPU, input and output handling, access to hardware resources and software resources. Most operating systems use kernels written in C because C is fast. I've already talked about a lot of this, but so it goes. So now let's talk about Linux. This is Tux the Linux Penguin. Tux the Linux Penguin. Linux is a family of free operating systems. Unix itself was free until 1984, when AT&T divested itself of Bell Labs. Unix then was made proprietary software by the people who bought out Bell Labs and all their intellectual property. This led to the creation of the GNU project, one of the first open source software movements in existence. How many people know open source software? Not nearly enough of you. So, the open source software movement can in some senses be traced back to the release of the initial GNU General Public License, which prior to that, software was treated the same way as any other intellectual property. It was subject to copyright, it was subject to legal prosecution should you violate copyright. The GNU General Public License kicked off the open source movement by releasing the copyright to the software licensed under the GNU General License in such a manner that other people could take that software and modify it, use it, compile it, anything they want to do with it. The source was open, right? This led to an explosion of biodiversity in the area of operating systems comparable only to the Cambrian explosion. One of the first operating systems to really take off after the initial development of the open source movement was the Linux kernel, which was written in 1991 by Linus Torvalds at the University of Helsinki. He named Linux after himself. It's Linus Unix. That's what Linux stands for. So there you go. Today Linux is the largest install base of any operating system, although only about 2% of personal computers use it. Anybody know how it has the largest installed base, despite not being in personal computers? Yes? It is used quite a lot in servers, like 95% of servers run Linux because it's way more efficient than Windows. Any other ideas? That's not what's doing it, though. Yeah?
That's like Windows or something.
Nope. Mac is actually a separate branch of Unix. They took it in a slightly different path. They branched off earlier. But anybody got an Android phone? Android is a Linux-based operating system. Android, I think, is overwhelmingly the most instantiated operating system on the planet right now. So, yep, Linux. So, in Linux distributions, command line interfaces are still commonly used, quite commonly used. Command lines have a higher skill cap than GUIs. It's just true. Your fingers can move faster over a keyboard than on a mouse, especially if you know how to touch type. How many people here know how to touch type? Wow, that is definitely something you guys want to learn how to do. If you guys think you're going to have a career as programmers. Learn how to use a keyboard properly. Yes?
When you say touch type, what do you mean by that?
To be able to use all 10 of your fingers while typing.
Oh,
Okay, fine. Good. What do they call it these days?
Typing.
They never taught us how to actually use it. They never told us how to
They never taught you how to touch type. Well, that's no wonder you don't know the name for the bloody thing. I guarantee if you were, yeah, if you were never formally taught how to touch type, you're not doing it correctly, and you will improve your typing speed if you learn how to do it correctly. So that's your homework. So,
We just don't think about the homework keys.
all right, simmer down. Thank you. The most commonly used command line interface in Linux distributions is called Bash, which stands for the Born Again Shell. There are various ways to access it. In Windows, you can use the Windows subsystem for Linux. On Macintoshes, you actually have Bash installed natively. You open up the terminal, which if you search for the application terminal, you should be able to find it reasonably easily. Then type bash, that'll flip you over to a bash prompt. And if you're in a bash prompt, all of the commands you see me use, you can use. If you're using Linux already, and you don't know where the bash prompt is, that's like a contradiction in terms. The best and most convenient way to do this course is with bash prompt. Boom. The other way to do it is to log into the Pascal server. As I understand it, the tutorials are getting good at telling you how to do that, so some of them anyway. Yeah. If you don't know how to get a bash prompt, learn how to get that this week. All right? Also, you're engineers, right? You need to be able to figure out how to do this kind of thing on your own. Because when you're in industry, nobody's going to tell you. And this is like easy mode. So there you go. I actually have a slide on this. We have set up a server for you to log into if the options on the previous slide don't work. Remote servers are accessed using a secure shell protocol, SSH. On Windows, it is common to use this in a client such as Putty. This is the download link. If the department has set up, a server for the class to use. For information, there's a whole thing about this on Avenue. Go check it out. Always remember to log out when you're finished. Okay? Question? A command line is a set of tools and which all share the common interface that you enter things on the keyboard, press enter, and it executes the commands that way. Bash is a particular command prompt interface, which is essentially an entire operating system wrapped up into one command line interface. Does that make sense? Question? Say again? Because it's a server, and if you don't log out, then it's like leaving your, like logging into a lab computer and then just walking away and not logging out when you're finished. Any other questions? So, almost all Unix and Unix-like systems support a comprehensive set of bash commands. If you want the full list, check out Wikipedia. Bash commands are extremely versatile. This is but a small selection of the types of things that you can do with bash commands. You can have the output of one command become the input of another. thereby chaining together long series of programs to accomplish some goal. This is what is meant partially by Unix's focus on modularity. The programs should be small, do something very specific, and be accessible to a user who knows what they're doing. That's the whole design philosophy. So for example, there is a whole program in Bash. All it does, take a file, select one line out of that, and return it. Right? Very useful stuff. You can collect Bash commands into scripts. That is to say, you can take a series of commands, put them in a file, have that file run by other programs. So you can automate the processes that you use to operate your operating system. You can take commonly done things that you do, write scripts for them, and then you don't even have to do them anymore. You can set up timers to do them at particular times of day. You can, like, this is what I mean when I say that the skill cap on command line interfaces is extremely high. Unless you have a command line interface where you're actually entering the text, putting that text into a file, you know, like, while possible to take a series of mouse clicks and put that in a file too, it's much more convenient to do that with actual text, right? Because that's what files are for. Bash commands can be invoked from programs written in C or Python. So you can take Bash scripts that you have written, activate those from programs that you write. It is an extremely versatile system. Any questions? We're not going to cover how to use Bash. We're not going to cover Bash scripting in this class. But be aware that it is extremely useful, and basically, you know, at the moment, it seems like the amount of work that you can get done is your intelligence multiplied by how hard you work, multiplied by how well you know how to use your computer. So, yeah. So, let's talk about the directory structure. The directory structure in Unix and Linux is hierarchical. That is to say, you have one root folder in which everything exists, which you can correctly think of as your hard drive, or at least a partition of your hard drive. And in that, you have a series of folders that expand out with more folders in them, etc., etc. So, you know. This is the root directory of Linux. It's got lots of folders, like where the boot stuff comes from, all of the where is it? User programs, you know, just a lot of stuff. Home is where your actual user like directory is contained, and that's where you keep all of your files, right? To access anything at this level, you need super user privilege. That's roughly equivalent in Windows to administrator privilege. Because, you know, Windows had to steal everything, make it less good, and change the names. So, directories containing files and subdirectories form a tree-like structure, tree in the computer science sense. Bash commands are executed within the working or active directory. So when you have a command, and this is pretty much true for any command line interface you may care to know about, when you enter a command, it is considered to execute in the folder that is the current working directory. there's always only one current working directory for any command prompt, right? You can change your active directory by using the change directory or cd command. This allows you to navigate the file system. cd ... allows you to raise yourself up one level in the directory. So, for example, if we're in documents/example and I cd to topic, I am now inside that folder. If I execute a command to make a folder, it will be made in this folder, not that folder. Make sense? So far, so good? Any questions? Any of you who are using the Pascal server, who are actually using the Pascal server as a bash prompt, you'll need to know how to do that. Here are some other bash commands. Cat displays the contents of a file. cd changes a directory. cp copies a file to another location. ls lists the contents of a directory. Man is short for manual. It will show any command's help information. Make directory makes a directory. ps lists all processes currently running. Probably don't need to know about that one. pwd lists your current working directory. rm removes a file. rmdir removes a directory if it's empty. You can also use rm-r to remove directories. And rep searches file contents. So let's see some examples. So, the tilde means home, so this is my home directory. I have a folder teaching. I have a folder for this class. There we go. A folder for this iteration of this class. There we go. CP code. There we go. Etc. etc. You see, I've been using the ls command without even realizing that I've been doing it. That's how second nature it becomes. Yes?
Is the slash necessary for the CD command?
It's inserted by the autocomplete, but it's not necessary. Yes?
Your folder has spaces in the title. But you type the spaces or?
Single quotes. Yeah. So you'll notice that the hours of work folder has some spaces in it, right? So if you try to cd to hours of work, it will consider each one of these to be a separate argument, right? So it'll think I'm trying to cd to hours and then of and then work or some other similar interpretation. In any event, too many arguments. So there's two ways of doing this. The first way, which I would recommend, is to just enclose that in single quotes, and it works. The other way to do this, incidentally, in most command line interfaces, you press up to get previous commands. You can also escape the spaces with the escape character. You remember the escape character? Boom. Good. So, go. We view contents by using cat. By the way, if you don't believe me that executables are stored in binary data, let's cat an executable. Nonsense. At least to humans. Good. Clear clears. We've got, so make directory, that's kind of self-explanatory. Copy, these are all file operations, more or less, right? Make sense? I would recommend going on the internet and finding a list of commands, printing it out, and pasting it somewhere inside of your workspace. That's the traditional way. So let's talk about that Putty client. What Putty is actually doing is it's providing a GUI interface to a Unix command known as the Secure Shell Protocol. SSH is a network packet protocol for secure remote login over insecure networks. So, essentially, a network protocol is an agreed upon format for information transmission. So, another network protocol that you might have heard of before, HTTP, or maybe IP, Internet Protocol. Does anybody know what HTTP stands for? Hypertext Transfer Protocol, very good. FTP? File Transfer Protocol. So this is how networking works in the very, very, very basic sense. But you guys are going to have to, because you guys are mechatronics people, and you're going to have to be dealing with things at the hardware level, you need to know what a data packet is, right? So, in general, a data packet is a series of bytes transmitted over some form of network. Ordinarily, you have a header with data following it. The header will specify many things: the origin point of the data packet, the destination of the data packet, how many bytes the data packet contains, security information, checksums, information relevant to the decoding of the packet, if it's an encrypted packet, all of these types of things, right? And if you kind of zoom in, you can imagine like this all being a series of bytes, labeled like, version number, destination, source, etc., right? A bunch of bytes lined up. Think of this as being a periodic table, right? It wraps around. I could put it all out in one line, but it would take the whole board type idea, right? So, SSH is one of these, all right? In short, you, the client, open up a shell on a remote server. So in this case, the client will be your computer. The server will be the Pascal server, which is being maintained by the IT guys in the department. Your computer sends data packets over the internet, which are received by the server, decoded, and this transmission of packets allows you to, basically you bring up a command prompt on your computer that looks like it's on your computer, but in fact, all of your commands are being transferred to the server, executed on the server, and then sent back to you for display, right? It's remote logging. So, this is the way that Putty accesses your server. It just gives you a nice little GUI for entering connection details. You can set it up where you're entering all the connection details on the command line, but if you're in Windows and trying to get onto a command line to begin with, it's useful to have a GUI, right? Any questions? So, this is what it looks like. The point of this course is for you to gain computer skills. If you don't know how to use this, you should read the documentation or ask someone who knows. Don't just flap about, I don't know what this is and nobody's told me. It's like if you don't know something, go find the answer. You people are supposed to be university students. You're supposed to be able to go find answers. It's like the most valuable thing about you. The most important computer skill is knowing when you need to look something up. Yes?
So how would we connect to Pascal server with this? Would we type in, like, is there like uppercase, lowercase, sensitivity?
Not generally on websites or URLs, and the Pascal.cas, that's a URL address.
That would be the whole thing. It'd just be
Yep.
Pascal server.cas.information.scat.
Yeah, that would be your host name,
Right.
right? So you'll also need to enter your login details. For more details, talk to your team. But yeah, so in general, you also need to be VPN'd in if you're off campus. But yeah, fortunately with the secure network protocol, you don't need much other than the URL of the thing you're trying to log into and your login details themselves, which, we sent that link around, which you should use to synchronize your CAS login with your Mac ID and take care of your credentials. And aside from that, the ports shouldn't be all auto-configured using the default parameters. It should be reasonably simple to set up. So, that being said, let's now talk about, now that we have the ability to all of us log into the same server, let's just take our brains for a moment and expand our minds and our potentialities. Let's consider an idea, let's consider that we were in a situation where everybody in this room had to work on the same software project. This is the type of situation you'll be in if you ever work for a company of any reasonable size. Consider video games. How many people work on a video game these days, like a big AAA release?
A lot.
Lots, hundreds, maybe even 1,000, So, do you think, my friends, that they send their code to each other by email? No. They have a more sophisticated mechanism. So, it kind of depends on how you're taking a project and dividing it up among all of these people. Generally speaking, a tried and true methodology for splitting software projects up into manageable pieces is to split them up into manageable pieces. You want divide and conquer, right? So, it's pretty common. You'll have, let's say you have 10 developers, and you have 20 different, classes in a piece of code, right? You would assign these classes to these developers. Every developer would get at least one, depending on the size and complexity, right? And that would be their domain. They would be experts in that one class, or that one file, or that one piece of the code. Each one of them would own a particular bit, right? So, this is fine. This is a pretty good one. This is known as code ownership. This is this strategy. Pros. Developers, so long as they're staying in their lanes, don't make changes to overlapping areas of the code. So long as your program is well designed, has a strictly and rigidly agreed upon and defined series of interfaces between these classes, everything works out. It's fine, it's good. Very nice. Developers also build expertise within an area of code and can make changes and updates faster. If you've been working on the same 3 classes for 6 months, you will gain some familiarity with them and can change them and adapt them more rapidly than someone who's never seen them before. Obviously. The problem, of course, is that one, projects don't always break down that easily. Two, we are in fact trusting humans, which is always perilous. And three, at a certain point, all of these various components do in fact need to be integrated. So the question remains, how do we approach this problem? In addition, you have the bus factor to consider, which is to say, if you have one developer who is in control and ownership of one piece of the code, right, knows it very, very well, but, writes it in such a manner that it is not easily understood to other programmers, and he gets hit by a bus, how does the project continue? Do you start over? Possibly. There are circumstances in which the loss of one developer can restart a project, or at least that segment of the project, which of course is bad and we don't want that, right? So, modern problems require modern solutions. Enter version control. Version control systems manage changes to software code and related files in repositories. Repository is a word you're going to have to become familiar with. Also, colloquially, repos. Repositories make it very straightforward to keep your files up to date with latest changes. Whenever changes are committed to the repository, committed is another important word, a new version of the file is created. The developers can access older or alternative versions of files so that detrimental changes can be reversed. Repositories do not just hold files, they keep a history of changes to those files. So that if, Johnny can't code, the developer that was hired, who knows why, because he was the nephew of the uncle of the grandson of the guy who owns the company or whatever, and he opens up the code, fills it with emojis, and then commits it, the code is not permanently damaged by this one rogue developer. You can roll it back to a previous version before all of the emojis were added, and poof, it's like they never existed. Repos are important in the open source community as they can be used to manage crowdsourcing projects. So you don't even necessarily have to know the other people who have access to the repository, right? They can just be internet people. Does that make sense? Any questions? We'll get into it in much greater detail. Oh, you have a question? No? Next time!